Hello, good morning. Can you hear me?
Yes, yes, sir.
Okay, thank you so much. How about the others?
呃
This will be your
熊姐，
first subject for today, or this will be your second subject?
那个老师说把摄像头打开。
I'll make my microphone. Okay, so while we are waiting with your classmate, no, but we need to start no our lesson, no. I'll just want to introduce, of course, the topic that we're going to discuss for the entire semester, no. And welcome to University of Perpetual Help System, no, Laguna, Philippines, no. And I'm so happy that we have a student from other country, no. So we appreciate the technology right now because we could able to accommodate students from other places. Okay, so for today, our topic actually is focused on software, and actually this will be an advanced software engineering. Okay, so looking forward that all of the students enrolled in this course is a BS Information Technology graduate or computer science or IT related courses. No, because this will be an advanced one, no, and we look forward that you will be able, of course, to create your own software, no, your own system, no. But prior to that, no, I just want to introduce myself. No, I am Dr. Marmila Abante, no. I graduated Doctor of Philosophy in IT and Doctor of Philosophy in Computer Science and Doctor of Philosophy in Computer Engineering. Now I am a guest lecturer, no, of University of Perpetual Help System Laguna. Now, to start with, no, as I mentioned earlier, no, looking forward that this class as a 10 students, no. So, the course or the software engineering provides an introduction to significant ideas, including software processes and agile methodologies. So most commonly during our college or baccalaureate degree, we are understand uh, maybe SDLC or the system development life cycle, uh, and other different platforms. But this time we look into a combinations of different methodologies, no, like agile and so on. So it also encompasses a comprehensive discussion or description of a vital software development task. So how we'll be able to do that to craft or to develop a software from the original software specification at the same time extending to the system evolution. So because in the field of information technology, we need to accept the fact that this is fast facing, no? Before it's just only industry 3.2, 1.0, 2.0, right now 5.0. And we have cloud computing, we had different, no, we have, of course, the cybersecurity is there. So the chapters contain within this section have been meticulously crafted to provide comprehensive support for a single semester software engineering course. Now, this will be the content, no, of the entire or the topics that we're going to discuss for the entire semester. So part one focus on the introduction. So we look into to this, no, that we will be able to understand you, or you will be able to understand the fundamental concepts and importance of software engineering. No, we could able to identify the key stakeholders in software development projects. No, let's say the owner, the stakeholders, the developers, the user, the end users, the tester, no, and so on. No, we recognize the challenges and risks associated with the software development because time is very important in software development, right? Our talent, no, and so on. Another is the software processes. So we look into the discussion of different software development processes. I mentioned waterfall, agile or spiral, and so on. We could able to compare and contrast various software development methodologies based on the given development process, no, and understand rule of the process improving in software development. In the chapter 3, we discuss about agile software development. So describe the principle and practices of agile software development. Now, we could able to identify the rules and responsibilities in agile teams and discuss the benefits and challenges of implementing agile methodology. So for chapter number 4, requesting engineering. So define the process of requirement elicitation, analysis, and validation. Explain the importance of clear, of course, and ambiguous requirements. No? Understand techniques for managing and changing requirements. Because in every changes, no, there are certain time, possible cost, no? When it comes to the requirements changes. No? Number 5, focus on system modeling. And chapter 6 in architectural design. For chapter 7, design and implementation, of course, what will be the principles and patterns, no? And what are the best practices and coding standards, no, for us to design and implement a codes, no, in software development, and code reviews and testing during implementation. Then after that, we focus on software testing, no? What are the types of software testing, test plan and test cases, and of course, the test-driven development. For number 9 or chapter 9, we look into the software evolution as what we mentioned earlier sa ating course, into our course description. No? So the reasons for software maintenance and evolutions, the managing software updates and changes. So if you are using Apple, no, most of the time they have some updates, no, and changes. Version control system and their role in software evolutions. Then for part 2, focus on, a while ago, part 1 is introduction, part 2 focus on dependability and security. So socio-technical systems, dependability and security specification, dependability engineering, security engineering, dependability and security assurance, no, for chapter or part 2. For part 3, focus on advanced software engineering, the software reuse, components-based software engineering or the CBSE, distributed software engineering, service-oriented architecture, which is also important. No, we need to look into the principles and benefits of service-oriented architecture. No, we need to understand on how also to design and implement services using this SOA. No, and understand the role of web services and service-oriented integrations. I think we are all familiar with embedded software. No? It's just not only implementing one, but we try to look or to embed our design software to the existing one. So it is important for us to understand the characteristics and constraint of embedded software. Let's say understand the real-time operating system and their applications, and hardware software code design and its challenges. Even the database migration must be considered in embedded software. Now, again, another is the aspect-oriented software engineering and its goals and cross-cutting concern in software and available techniques and tools and aspect-oriented software engineering. For part 4, focus on software management. No? So, this will be focused on the project management side, no? The project planning, scheduling, resource allocation, risk management, and project tracking and control. So for project planning, okay, we look into the scope, schedule, and resource allocation. I think we are all familiar with work breakdown structure in Gantt charts during our baccalaureate degree program, and how we'll be able to identify the critical path analysis and the resource labeling. It is already discussed in our undergraduate program or in your baccalaureate degree, but we are going to discuss more advanced one related to project planning. No? Then quality management, no, reliability and usability. Most commonly, no, especially if we wanted to check our software, created software, we look into some quality management, no. And let's say we use ISO standard 9126 or ISO standard 92. It depends upon to your software, such as web, pure software development, and so on and so forth. And we look into the quality assurance techniques katulad like testing and inspection. We could able to understand the metrics and measurement for quality management. Then chapter 25 focus on configuration management, the version control, the impact of configuration changes, configuration management, and software development. Okay. Then, process improvement for chapter 26, describe the goals of process improvement in software development. Benchmarking techniques, no? We have different also models, no, for process improvement like CMMA and Six Sigma for improvement. And this will be the detailed course outline. Okay, so part 1 to 4. Actually, we have textbook available in Lazada or Shopee. I will send it to you maybe later, and looking forward that we will be able to create a Facebook group messenger for us to have an easy communication. No, this will be a textbook, no, that we could able to utilize for the entire semester. Okay. Then another references textbook, but we have also references, no? Yan. So the grading system, of course, attendance is 10%. Project, so you need to develop your own software. So just only a simple software that wherein we could able to apply the knowledge we gain from the discussions or lecture of our advanced software engineering. We have an oral response, set work assignment, journal review, and final examination and project presentation. Okay? Then, again, I am your professor, no? Dr. Marmelo Abante. This will be my academic qualifications. Okay? And this will be my Facebook account, no? Looking forward that we will be able to have, as I mentioned earlier, a Facebook group messenger for easy communication. Okay? So I'll just want to ask for those who have question. No, but prior to that, I'll just want to share my Facebook account for you to add. Looking forward. No? See. Oh, yeah, I forget. Later on. And I'll just post it to our stop sharing. Sorry. Stop sharing. Do you have any clarification so far? Because I don't know if you will be able to deliver a presentation, because I will provide an assignment for each and every one for you to present the topic during our discussion. So our class is every Saturday in the Philippines, 10 a.m. to 1 p.m. I don't know if we have the same time in your place, but I think from China, we have the same time, no, in China and the Philippines, if I'm not mistaken. Okay? Okay, actually, I visited China for how many times, no? I always be there, no, in different areas, no, in China. So I think I visited already 5 or 6 areas in China, no, because I am also for benchmarking purposes and some meetings, no, seminars, especially during Education Week, no, in China last year, no. I will be there for how many weeks? I think 2 weeks or 3 weeks. For almost 1 month, I will be there in China. Okay, so I just want to give you an overview of what we have able to discuss for the entire semester, because this will be our first meeting, and maybe your classmate is still enrolling, no, in this course, no, and they were not able maybe, no, to attend for today. But I don't want to waste your time attending this class without some additional inputs, or you will be able to relearn or learn from my discussion. Okay. The modern world, no, cannot functions without software, right? I hope you believe so. Computer-based system, no, regulate national infrastructures and utilities, and most electrical items incorporate a computer and controlling software. So, industrial manufacture and distribution, as well as the financial system, are entirely automated right now. And the entertainment sector, which includes the music industry, of course, the computer games, and cinema and television, is heavily reliant on software. As a result, software engineering is critical, no, to the operations of national and international societies. No? So, software systems are intangible and abstract because they are not only limited by the qualities of materials, physical laws, or production procedure. So this simplifies software engineering because there are no natural boundaries to software capabilities. However, due to a lack of physical restriction, software system can rapidly become exceedingly complicated, difficult to understand, and costly to alter. And there are numerous sorts of software systems, no, ranging from simple embedded system to huge global information system. So it is futile to look for universal software engineering notations, methods, or procedures because different types of software necessitate distinct approaches. Like creating an organizational information system, no, let's say in your respective work, no, it is not the same as creating a controller for a scientific instrument, right? Neither of this system is remotely similar to a graphics intensive computer game. All of these applications require software engineering, although not all of them require the same software engineering methodologies. As I mentioned earlier, there are still numerous reports of software projects failure and software failures because software engineering has been challenged as being insufficient of modern software development. However, many of these so-called software failures, no, in my opinion, are the result of two factors. Number one, rising expectations. So the demands vary as new software engineering approaches enable us to design larger, more sophisticated systems. So system must be constructed and supplied more quickly. Larger, even more complicated systems are required. And system must have previously thought to be impossible capabilities. So existing software engineering approaches are incapable of meeting this increased expectation, and new software engineering techniques must be developed. And this will be your now responsibility to look into this one. And looking forward that during your educational journey, you will be able to develop new software engineering techniques. Now, looking forward with that. Unrealistic. Number two, of course, is unrealistic expectation because without applying software engineering principles and techniques, it is relatively simple to develop computer programs. So, as their products and services have expanded, so many businesses have strayed into software development. They do not use software engineering techniques in their daily work. As a result, their software is frequently more costly and less reliable than it should be. So to address this concern, we need better software engineering education and training. Software engineers should be proud of their accomplishment. Of course, there are still issues with designing complex software, but without software engineering, we would not have explored space, the internet, or contemporary telecommunication. So all modes of transportation would be more unsafe and expensive. So software engineering is or has made significant contribution, and I am confident, no, that its contribution in the 21st century will be considerably bigger. Now, professional software development. No, many people write programs. No, our students. No, a lot of programmers. No, people in business build spreadsheet programs to help them do their jobs more efficiently. Scientists and engineers write programs to process experimental data, and hobbyists write programs for their own amusement. So, the great majority of software development, on the other hand, is a professional activity in which software is built for specific commercial reasons for incorporation in other devices or as software products such as information system. CAD, no, or computer-aided design system, and so on. So, professional software, which is meant for use by people other than the developer, is typically created by teams rather than individuals, right? So, throughout its existence, no, it is maintained and altered. Rather than individual programming, software engineering is intended to support professional software development because it covers approaches that aid in program specification, program design, and program evolution, none of which are generally applicable to procedural software development. No? There are some frequently asked questions that help us gain a general picture of what software engineering is all about. And many people believe that software is just another name for computer applications. However, when discussing software engineering, software includes not just the programs themselves, but also related documentation and configurations data required to make this program functions properly. A professional software system is frequently specified, no, or more than just a single program, no. The system is often composed of a number of distinct programs and configurations files needed to configure this program. So again, it may comprise system documentation that specifies the system structure needed, user documentations that explain how to use the program, or we say that user documentation, no, and or a user's manual, no, the other terminal is the user's manual, no. So when you write a program, no, this is a significant distinction between professional and hobbyist software development. Okay, no one else will use it, no, or you don't have to bother about developing program guides, documenting this program design, and so on. However, if you are building software that will be used by others and changed by other engineers, you will likely be required to supply additional information in addition to the program code. So, when we say software, again, software is a computer programs and associated documentation software products may be developed for a particular customer or may be developed for a general market. So what will be the attribute, no, of having a good software? A good software should deliver the required functionality and performance to the user and should be, again, take note, it must be maintainable, dependable, and usable. As I mentioned earlier, software engineering is an engineering discipline that concern with all aspects of software production. The fundamental of software engineering activities is software specification, software development, software validation, and software evolution. Now, maybe somebody were asking, how do we differentiate software engineering to a computer science? Now, system engineering, or how you'll be able to differentiate system engineering to software engineering. Okay. System engineering is concerned with all aspects of computer-based system development, including hardware, software, and process engineering software. Okay, so software engineering is part of this more general process. No? So, what are the key challenges, no, in facing software engineering? For me, coping with increasing diversity, no, demands for reduced delivery times and developing trustworthy software is the challenges, no, facing by software engineering. And of course, we are all curious about the cost of software engineering. Roughly, 60% of software costs are development costs, and 40% are testing costs. For customized software, evolution costs often exceed development costs. Now, what are the best software engineering techniques and methods? No? Siyempre, of course, we are looking into it. No? While all software projects have to be professionally managed and developed, different techniques are appropriate for different types of system. Let's say, for example, games should always be developed using a series of prototypes, whereas safety critical control system required a complete and analyzable specification to be developed. You can therefore say that one method is better than another. Okay, what difference has the web made to software engineering? So, the web has led to the availability of software, services, and the possibility of developing highly distributed service-based system. Web-based system develop has led to important advances in programming languages, and software reuse, So, the organization, because the organization that creates the program control is the software specification in general goods, or in generic goods. So, another thing, of course, is that software engineering, is focused on different product characteristics, as I mentioned. Number one, maintainability. Software should be written in such a way so that it can evolve to meet the changing needs of customers. This is critical attribute because software change is an inevitable requirement of a changing business environment. Another is the dependability and security. We as developer, as a software engineer, we need to consider dependability and security. Software dependability includes a range of characteristics including reliability, security, and safety. Dependable software should not cause physical or economic damage in the event of a system failure. Malicious users should not be able to access or damage the system. Another is efficiency. Software should not make wasteful use of system resources such as memory and processor cycles. Because efficiency therefore includes responsiveness, processing time, memory utilization, and others. And another consideration is the acceptability. Your software must be acceptable to the type of users for which it is designed. And this means that must be understandable, usable, and compatible with other system that they use. This will be a qualifications of a software or a consideration in crafting our software. Now, do you have any questions so far, or do you have an additional inputs? I don't know what will happen to your classmates. It's already almost 11, but they were not around. I just want to give more additional inputs in these discussions. Software engineering also typically focus on the key concepts and practices that build on foundational software engineering principles. Number one is the software design patterns. No? Introduction to common design patterns such as singleton, factory, no, observer, and decorator. It must focus on the understanding how patterns solve recurring system design problems. And of course, apply these patterns into a real-world scenario. Now, actually, we are now in the intermediate software engineering discussion, no? Because I believe that you are already finished the introduction of software engineering. The software engineering, intermediate software engineering process focuses on enhancing core principles, no, to build more efficient, maintainable, and scalable system. So as I mentioned earlier, we looking forward to discuss the design patterns, which offer reusable solutions to common design challenges and a software architecture, where different style like microservices or layered architectures are analyzed for performance and scalability. So emphasis is placed on the code quality, maintainability, and version control best practices for managing projects collaboratively. So testing, particularly test-driven development, is crucial for ensuring reliability, alongside agile and DevOps practices that streamline development and deployment. So additionally and lastly, security considerations and performance optimization are addressed. Syempre, of course, to safeguard software and improve its efficiency. So our discussions for the entire semesters maybe go around with these introductions. Okay? So I'll just want to take a picture as part of our attendance for today. So even I wanted to discuss more, but majority of our classmates was not around, no? And wait, hold on. Okay, how about the other one? Can you open your camera or not? Okay, so 1, 2, 3. Okay, so thank you so much for attending our first meeting and see you next week. God bless everyone. Stay safe. God bless. Bye-bye.